بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some exercises about section 4.2 linear programming. Use the given feasible region determined by the constraints inequalities to find the maximum and minimum of the given objective function if they exist. So here, the constraints is not given in the question, but the region is graphed for us, and the corner points even are given. So we know that all what we need to do is to use the corner points, substitute them in the objective function, and find the maximum and the minimum values for the objective functions. So these are the corner uh, points. I have 2, 2, 6, 4, 12, 4, and 6, 1. All right. So this is C. 2 times 2, 4, plus 14, that's 18. 6 times 2 is 12. Plus 7 times 4, that's 28. So 12 times 28 is 40. 12 times 2 is 24. Plus 7 times 4, so plus 28. That's 52. 2 times 6 is 12. Plus 7, that's 19. So maximum value of C is 52 at x equals 12 and y equals 4. And minimum value of C is 18 at x equals 2 and y equals 2. So that's the answer of this problem. Another one. Well, this region is not bounded, unbounded, and it's not closed, okay, because it continues to infinity. The corner points are there, so there will be a minimum point for f, but there will be no maximum. So no maximum value, okay, because it's not bounded up from above. So we use again the corner points, all the corner points. We have 0, 6, 2, 2, 4, 1, 8, 0. We substitute them into the original function. So this would be 30, 8 plus 10, that's 18. 4 times 4, 16, plus 5, that's 21. 4 times 8 is 32 plus 0. So we cannot say that the maximum is 32 because, for example, just choose this point, 9, 10, 10, okay? So it will give you more than 32. So 32 actually is not the maximum. It cannot be the maximum. No maximum value for this function. But the minimum value of the function f is 18 at x equals 2 and y equals 2. The graph of the feasible region is shown. Find the corners of each feasible region. So the corners are not given here. Well, this is a corner point, and this one, this one, this one, and this one. 2, 4, 5, 5 corner points. Well, for this point, it is the y-intercept of this function. So to find the y-intercept of this line, I put x 0, so 2y equals 80, so y is 40, so this is 40. So it's clear that uh, each part here, or I mean the unit of measure here is 5. Okay. So this point is the x-intercept of this line. So to find the x-intercept, I put y0. So 4x equals 140. So 140 over 4 is 35. So this is 35. So each one here is also 5. So the corner points, this region is bounded and uh, closed. So the corner points are, I have 0, 0 is a corner point, 0, 40 is a corner point, 35 and 0 is a corner point, and still these two corner points. Okay, to find this one, this is the intersection point between the line 4x plus y equals 140 and this line, which is x plus y equals 50. So I will keep the first line as it is, multiply the second by -1, adding, I have 3x, this will be cancelled, and 140 minus 50 is 90, so x is 30, and y would be 50 minus 30, 20. So this point is 30 and 20. So this is another corner point. Now what about this point? This is the intersection of this line x plus y equals 50 and this line, which is x plus 2y equals 80. So I'll just multiply the first one by -1, keep the second one as it is. When I add, I get 2y minus y, that's y, equals 80 minus 50, that's 30. And then x would be 50 minus 30, 20. So the point is 20, 30. So this point has coordinates 20, 30. So 20, 30 is also another corner point. So these are the 5 corner points. Let us replace them in f. F would be 0 here. 8 times 40 is 320 here. 5 times 35 plus 0. So this is 175. 5 times 30 plus 8 times 20. 310. 5 times 20, that's 100, plus 8 times 30. So that's 340. So maximum value of f is 340 when x is 20 and y is 30. While the minimum value of f is 0 when x is 0 and y is 0. So this is the solution of this problem. Another question. Well, to find the coordinates of this point, I don't need this point. Why do I need it? I need the corner points. And the corner points are, this is a corner point, this is a corner point, this is a corner point, and this is a corner point. So 4 corner points for the blue region, and it's an unbounded region. So there is no maximum value, but there will be a minimum at one of these corner points. So how to find the coordinates of this point? This is the y-intercept of this line, 3x plus y equals 45. So the y-intercept, I put x 0, so y is 45. So this is 45. So the first corner point is 0 and 45. Okay. Now this corner point should be easy to find. It is the x-intercept of this line, x plus 2y equals 50. So if I put y 0, x is 50. So 50 and 0 is one of the corner points. Now let us find this corner point. Well, this corner point is the intersection point of this line, which is x plus y equals 35, and this line, which is x plus 2y equals 50. If I just subtract, x minus x is 0, 2y minus y is y, 50 minus 35 is 15. So y is 15 immediately. Okay. I subtracted the first equation from the second equation. Now, x would be, if I put 15 in the first equation, so x would be 35 minus 15, and that's 20. So the point 20 and 15 is a corner point, which is this point. Okay, so this is the point 20 and 15. Well, what about this point? Well, this point is the intersection point between this line, which is 3x plus y equals 45, and the other line, which is this line. The equation of this line is x plus y equals 35. I will also subtract 3x minus x is 2x, y minus y is 0, 45 minus 35 is 10. So x is 5. If x is 5, then y is 35 minus 5, which is 30. So this point has coordinates 5 and 30. So 5 and 30 is also one of the corner points. 1, 2, 3, 4, 4 corner points. So it's time to substitute in the objective function g. So 3 times 45, 135. 50 plus 0 is 50. 20 plus 3 times 15, so that's 65. 5 plus 3 times 30, that's 95. So 135 is not the maximum because you can choose, for example, 100 will be in this region, and it will give you much more than 135. So there is no maximum value. But the minimum value is 50 when x is 50 and y is 0. Here, solve the following linear programming problem. with these conditions, x greater than or equal to 0 and y greater than or equal to 0, plus these constraints. So these are here in these questions are always there. Okay, so to graph, first we need to graph the region. So let me start by graphing this line x plus y equals 6, 0, 6, 6, 0, and the line 2x plus y equals 10. If x is 0, y is 10, and if y is 0, x is 5. So let us sketch the graph of the region. This is 0, 6, and this is 0, 10. This is 5, 0, and this is 6, 0. So 5, 0 with 0, 10. And 6, 0 with 0, 6. Okay. And now, if I replace xy by 0, 0, I get 0 less than or equal to 6. Where is this line? It is here, x plus y is 6. This line is 2x plus y is 10. Okay, so this is correct. So it goes down. Okay, and 0, 0 here, 0 is less than or equal to 10. That's also correct. So the graph is here. Y is less than or equal to 4. Well, this is the line y equals to 4 and less than will be below this line. Also x greater than 0 and y is greater than 0. So where is the region? This is the region. This is the region that satisfies all of these conditions. All right, all of these conditions. And the corner points are this point, and this point, and this point, and this point, and this point. So we have five corner points. Well, corner points, and the objective function is called f. Well, I have 0, 0 as a corner point, and this point is, this is y is 4 here, so 0, 4. And this point, you see 5 here, so it's 5, 0. And I need to find this one and this one. So for this one, it is the intersection of the line x plus y equals 6, okay, this line, and the line 2x plus y equals 10. If I subtract 2x minus x is x, y minus y is 0, 10 minus x is 4. So x is 4 here, and if I put 4, then y will be 6 minus 4, so y is 2. So this point has coordinates 4 and 2, if my graph is accurate. So 4, 2 is another point, another corner point. And now this point, y here is 4. It is, in fact, the intersection point between y equals to 4, this line, and the line x plus y equals to 6. So if y is 4, then x is 2, and the point is 2, 4. Now, the region is closed and bounded, so we will have a maximum and a minimum. 0, 0 will give you 0. 3 times 0 plus 4 times 4 is 16. 3 times 5 plus 4 times 0 is 15. 3 times 4 is 12. Plus 2 times 4 plus 8, and that's 20. And 3 times 2 is 6. And 4 times 4 is 16. So that's 22. So the answer would be maximum value of f is 22 at x equals 2 and y equals 4. And the minimum value of f is 0 at x equals 0 and y equals 0. Another question. Let me start by graphing x plus y equals 7. So 0, 7, and 7, 0. The other line, 2x plus y is 12. So if x is 0, y is 12. And if y is 0, x is 6. Okay. The third line, x plus 3y is 15. So if x is 0, y is 5. And if y is 0, x is 15. Let us sketch the graph. 0, 7, and 7, 0. This is the first line. And we can check immediately 0, 0. 0 less than or equal to 7, that's correct. So the graph is below this line. The second line, 0, 12, 6, 0. So this one and this one, this point and this point. And let me check 0, 0 immediately in this inequality. 0 less than or equal to 12, that's correct, that's good. So the graph is also here below this line. The last line, 15, 0. So this is 7. This point and 0, 5. This point. So this is the line. And in fact, I am not sure whether now this point of intersection would be the same point or not. Okay. The graph here needs to be accurate to make sure that where is this line? Okay. We will see from the intersection points what would happen. 0, 0 is less than or equal to 15. This is correct. So the graph is also here. And of course, x should be greater than 0 and y greater than 0. So this is the region. Okay. Now, what are the corner points? Corner points. 0, 0 is there. This point is 6, 0. and this point is 0, 5. And now let me write the equations of the lines. This is the line x plus y equals 7. And this is the line 2x plus y equals 12. And this is the line x plus 3y equals 15. Now we need to find this point. Well, let us put the corner points in black. Okay, so let me start by this one. Well, this is supposed to be the intersection of the line 2x plus y equals 12. This line and this line x plus y equals 7. Subtract 2x minus x, y minus y is 0, 12 minus 7 is 5. If x is 5, y is 2, so the coordinates of this point is 5 and 2. Okay, now let us concentrate on this point. Well, this one is the intersection if this graph is okay, then this is not okay. So this is the only this one. This is the only corner point between this line, which is x plus 3y equals 15, and the line x plus y equals 7. So 0, 3y minus y is 2y, 15 minus 7 is 8. So y is 4 and x is 3. So this point has coordinates 3, 4, and this one 5, 2. Okay. And this one 6, 0. That's good. Okay, that's enough. So the intersection point between the two lines 2x plus y equal this intersection point does not belong to the region. And let us find it to check whether it belongs to the region or not. This is just because my graphing is not accurate. So I need really to evaluate this point. So this point is the intersection point between 2x plus y equals to 12. Okay. And the line x plus 3y equals to 15. If I subtract 2x, no, subtraction here will not solve the problem. So I need to multiply the second equation, for example, by negative 2. So negative 2x minus 6y equals negative 30. So negative 5y, okay, would be 12 minus 30, negative 18. So y is 3.6. So y is 3.6 and x is, if y is 3.6, then 12 minus 3.6, 8.4 over 2, then x is 4.2. So if we have this region 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 6, 0, 0, 5, and 1, 2, 5, 2 is here, and 3, 4 is here. Okay, so we have, this is our region almost. So 3.6, 4.2, 4.2, and 3.6 would be somehow above this region. It is not in the region, okay? So I think everything is fine, and these are the only corner points, and we now put them in F, substitute in F. So 0, 2 times 6 is 12, plus 6 times 0, 2 times 0 plus 6 times 5, so this is 30. 2 times 5, that's 10, 6 plus 2, 12, 10 plus 12 is 22, 2 times 3 is 6 plus 24. 6 plus 24 is 30. The region is bounded uh, and closed. So there is a maximum and a minimum. Everything is fine. Okay. So the maximum value, the answer would be maximum value of the function f, the objective function, is, what is the largest number? 30. Okay, we have 230. So is 30 at on the line connecting which points 0, 5, and 3, 4. So this is 0, 5, and 3, 4. So this line, I'll do it in black. This line, along this line, the function is maximized, and the minimum value of f is 0 at x equals 0 and y equals 0. Notice that if your graph is accurate, you will find out whether where are the corner points exactly. Okay, so this is the solution of this problem. Another question, minimize this function subject to these two constraints. Do we have x greater than 0 and y greater than 0? Yeah, up to 24, x is always greater than 0 and y is greater than or equal to 0. So this is the last question, and we have x greater than 0 and y is also greater than 0. So the line is 5x plus 2y equals 16, and if x is 0, y is 8, and if y is 0, x is 16 over 5, and that's 3.2. And the other uh, line, is 3x plus 7y is 27. And if y is 0, then x is 27 over 3, which is 9. And if x is 0, then y is 27 over 7. And that's almost 3.9. Okay. So let us sketch the graph of this region. 1, 2, 3.2. This is 3.2. This is 8, 0, 8. So this is the first line. This is the line with equation 5x plus 2y equals 16. The other one, 1, 2, 3, 4, here 3.9 and 9, 0. So this is the line, okay, with the equation 3x plus 7y equals 27. Now let us check 0, 0. 0 plus 0 greater than or equal to 16. This is not correct. So the line 5x plus 2y and the graph is above this line. And here 0 greater than 27. This is also not correct. So the graph is above this line. But notice that the graph is also starts y equals to 0 and y should be greater than 0 and x greater than 0. So from here to here, then to here, and then to here, and the graph continues like this. Okay, so this is the region. The region is above the x axis and above the y axis. Okay, here, that's the region. So no need now for this line and this arrow, the arrows. Okay, so that's the graph of this region. It's clear that this region is unbounded and not closed, and that this is a corner point, and this is another corner point, and this is another corner point. So there are 3 corner points of this region. So let us write the corner points. Here, 0, 8 is a corner point, that's clear. And this one is 9, yeah, 9, 0 is another corner point. And now we need to find the coordinates of this point. And to find the coordinates of this point, we find the intersection points between the lines, the 2 lines. So I have 3x plus 7y equals 27 as this line, and the other line is 5x plus 2y equals 16. Well, to solve these 2 lines together, uh, I will multiply the first equation by negative 5, okay, and the second equation by 3. So I will have negative 15x, negative 35y equals negative 5 times 27. So that's negative 135. And the other equation, 15x, the second equation, plus 6y equals 3 times 16, that's 48. Add negative 35 plus 6, that's 29 with negative sign. And negative 135 plus 48 is negative 87. And when I divide negative 87 by negative 29, I get 3. So y is a 3, 3. And if I put y3 in the second equation, for example, so 5x would be 16 minus 6, which is 10, and x would be 2. So the coordinates of this point is 2 and 3. So this is the third. Okay, this is the third corner point. Now I put it ng. So 7 times 0, 6 times 8, that's 48. 7 times 9 is 63 plus 0. And 7 times 2 is 14, plus 6 times 3 plus 18, and that's 32. Notice that this region is not bounded, so no maximum. Well, he did not ask about maximum. He knew that it is unbounded, so he needs the minimum. So what is the minimum? It's 32. So the minimum value of the function, what is the name of the function? G is 32. Where does it occur? At x equals 2 and y equals 3. This is the end of these exercises. Hope you understand the subjects well by now.